it is similar to chapter 4. Okay, consumers and industrial chemistry. Yeah. Okay. So in this chapter, we are going to discuss few topics. Okay, let's see one by one. So number one, we are going to see green technology. Okay, then oils and fats, cleaning agents. Okay, under cleaning agent we have two soap and detergent. Okay. Then after that, we are going to discuss the food additives also. So under food additives, there are 1, 2, 3, 4, 5, 6, 7, or 7 types of food additives. Okay. Now next is under medicine. Medicine, actually 2 types. Classic or traditional medicine and modern medicine. But we focus to modern medicine. Modern medicine, we have 1, 2, 3, 4, 5 modern medicine. Then after that, we are going to discuss the nanotechnology. Okay. Then finally, it's under cosmetics. Okay. Cosmetics. Then, so we are going to look into one by one. But all this actually is very, very like the introduction only. So if you further your study in the higher education, later you will learn in details. But in the SPM level, just introduce to you what is that only. Normally, it's a definition. And then some of the important knowledge that you need to know under that part. That is all. Not many things actually. Okay, so we look into one by one. So first we look into the oils and fats first. Oils and fats. So oils, what it means by oils? Oils and fats actually they are natural esters. Natural esters. So they are formed by esterification. Still remember of alcohol, glycerol, or what propan 1, 2, 3 triol with fatty acids. Okay, so fats actually are triesters. Triesters. Okay, they are chemical. These oils and fats are chemically very similar but different in the physical states. Okay, physical states. So what is mean by alcohol glycerol? Okay, so glycerol is an alcohol with 3 hydroxyl groups. 3 hydroxyl groups known as propan 1, 2, 3 triol 1, 2, 3. There are 3 OH triol. Triol. Okay. Now how about the fatty acids? It's a long chain of carboxylic acid with long carbon change. Okay, RCOO. But here we learned this already. This is carboxyl group. This R actually is a long change. Okay, can be 10 to 20. Okay. Then, okay, we look into the general equation for esterification reaction. Okay, so esterification reaction, you focus to ester. Still remember the ester. COO, this one. Okay. So this one is called carboxylate, right? Carboxylate. Okay. So you see, this one is glycerol. Glycerol is, there are 3 moles of hydroxyl here. Okay. This one is glycerol. Okay, then it react with 3 more of fatty acid. This one is 1 fatty acid. Okay, 1. There are 3. This one not combined, but this one is combined. 1 glycerol. Glycerol means 3 hydroxyl group. So they will form the water. Okay, here. Okay, means release 3 or produce 3 more of water. Okay, then after that you combine them together. This one means it connect to here. Sorry, this one connect to here. This all connect to this C. Okay, so it becomes like this. Okay, so you combine. Okay, like this. So this one is called oil and fats. Okay. So R, this one, it represents the hydrocarbon change. The alkyl groups that are same or different. So glycerol with fatty acid produce oil and fat, or fat with water. Okay. Then oil and fats molecules are made out of 2 parts. Okay. First part derived from glycerol. Okay. This one derived from this part, meaning that this part. Okay. This part from glycerol. Then another part is from fatty acid. Okay, Any questions so far? Okay, huh? Michelle, okay, not Michelle? Okay. Good. Now, what are saturated fats molecules? Do you remember what is mean by saturated? Anybody know what is mean by saturated? Or what is mean by unsaturated? Saturated or a single bond, yes. Or a single bond. Correct. Saturated or a single bond, no double bond. Double bond is unsaturated, no? Okay. So saturated fats molecules are ester of saturated fatty acid. So they contains a single carbon-carbon covalent bonds. Okay. So like this, or a single bond between the carbon-carbon, not this one. Don't confuse with this one. This one is C double bond O. Okay, saturated is C and C, not C and O. Understand? So this one is not related here. So all are single bond. Okay. So example, glyceryl tristearate. Okay, is a saturated fat. Saturated fats. Then how about the unsaturated? Okay, it contains what? Single and double. Okay, single and double. At least got one carbon-carbon double bond between the carbon atoms. Right. Okay, for example, like this. If you see this, it has carbon-carbon double bond, so unsaturated. Okay, contains double covalent bonds between the carbon atoms. So this is called unsaturated. Okay. So if there is only one double bond in the fatty acid molecule, so the fat forms is a mono unsaturated. Mono means single, only one. Okay. Then if there are more than that, it forms a poly unsaturated. Poly means more, a lot. Okay. Next, let's see. Okay, what is a saturated and unsaturated oils and or fats? The oil and fats are mixture of saturated and unsaturated fats molecules. So an oil or fats classify as what? As saturated. Okay, saturated. If it has more saturated fat molecule compared to unsaturated. Okay, for example, the animal fats. See which one is more. If saturated fats molecule more, meaning that we can consider or classify it into saturated. Okay, but if it is unsaturated, if it has more unsaturated, okay, molecules compared to saturated fats molecule, so it is called unsaturated. For example, vegetable oils except the coconut oil. Okay, now we see the comparison. Saturated, okay, you can note down here, saturated, this one is single. Okay, unsaturated double carbon double bond. Okay. So bonds, only carbon single bond in the hydrocarbon chain. This one got carbon double bond and single bond in the hydrocarbon chain. Melting point, this one is higher, this one is lower. Okay. Relative molecular mass, this one is higher, this one is lower. Physical state, okay, so this one fats is a solid, unsaturated is a liquid, liquid form. Source, fats from animals. Unsaturated fats, it is from vegetables. Okay, vegetable oils. So sometimes you see when we talk about fats, it is come from the animals. Okay, then oil is come from vegetables. Okay, can differentiate, So what is the importance of the oils and fats? So you can see oils and fats provide energy, provide energy for our body, build membrane cell and the certain hormones, then dissolve certain vitamins and for absorption. Okay. So what are the sources? Sources of oils and fats. Okay. Fats found in animals like cow and goat are what? Solid. Okay. Solid. At room temperature. Example, animal fats are butter, cheese. Then fats from plants are liquid. At room temperature, they are called what? They are called oils. Okay. Example, peanut oil, soybean oil, corn oil, all these are called oils. Okay. Now, what are the process? Okay, this one we learned already, Do you remember or not, class? This is under hydrogenation, right? Still remember? Hydrogenation, manufacturing of the margarine. Catalyst is the nickel. Temperature is 180 degrees Celsius. Still remember? Okay. So the double bond break to form two new single bond here. So hydrogen got in. Nickel and 180 degrees Celsius. Okay, any questions so far? Can follow? So hydrogen process is carried out by passing the hydrogen gas through the liquid hot oil in the presence of nickel as a catalyst. Temperature is 180, pressure 4, atmospheric pressure. But normally we focus to temperature enough. Then nickel as a catalyst. Okay. Now, explain why the physical state of oil turned into solid after hydrogenation. Because what? Relative molecular mass for oil is increased. So as more and more double bonds are added with hydrogen, okay, so the strength of the force of attraction between the molecules, right, becomes stronger and more energy needed to overcome the force. So the boiling point of the oil increase and the physical state change from liquid to solid. Okay, so example of uses. Okay, source of energy, for example, biodiesel, produced from vegetable oils, used for cooking, and or animal fats. Okay, and then biodiesel, renewable, it can be used as in existing diesel engines without modification. Okay, this is for energy. And next one is a nutrient. Nutrient, for example, vitamin A, D, and E, K, is soluble in water, but it is soluble in fats. So these vitamins are part of the balanced diet to maintain the good health, right? So addition of fats to diet of dairy animals can improve the fertility and milk production. Okay, next in industry, vegetable oils are used to make soaps, skincare products, candles, perfume, other personal care like cosmetic products. Okay, now. What are the effects of eating good with high content in fats and on health? Okay, high content in fats. Good or not, class? Good or not? Okay, it depends. So eating food in high animal fats increase the level of what? Level of LDL. Okay, what is mean by LDL? In blood. Okay, there are two types of cholesterol actually under cholesterol, LDL cholesterol and HDL cholesterol. Let's see what is mean by LDL cholesterol. So LDL cholesterol cause the what? Cause the plaque deposit on the wall of the veins and arteries, which can lead to heart attack and stroke. Okay, so which is not good. HDL cholesterol, okay, reduce the deposit on the artery walls. Okay, this one will cause the plaques. This one reduce the deposit down. Okay, next, animal fats. Okay, or saturated fats contains higher LDL cholesterol, whereas vegetable oil, okay, unsaturated or fats contains higher HDL cholesterol. So in other words, which one is better compared to another one? Animal fats or vegetable oil is better a bit, vegetable one. Okay. Okay. So HDL because it will reduce the deposit. Okay. If LDL, it will cause a plaque deposit meaning that your bladder will block the veins and arteries, right? Okay. Then it will cause a heart attack or then stroke. Okay. So this is all about the oils and fats. Okay. So oils is for vegetable, fats is for animals. Okay. Is that okay? Okay, 5.2, we are going to see the cleaning agents. Okay, this one is in our old syllabus, still have. Okay, then this one more popular. Okay, for me, if compared to the toddler. Okay, but don't know the new syllabus, they emphasize it in the exam or not. Huh? So you have to, we just have to get ready. Okay, now, cleaning agents. Okay, salt. First, we look into the salt. Salt, sabun, sabun. So salt are sodium or potassium. Salt of fatty acid. Okay, so right now. Yeah, so it is the potassium salt or sodium salt of fatty acid. Okay, now we look into what is mean by fatty acids. Okay, so fatty acids are organic acid with long chain, okay, which is CnH2n plus 1 COOH, and it will be more than 10, okay, maybe 15, 16, 17, 18. Okay. So fatty acid found naturally as an ester with the alcohol glycerol. Okay, what does it mean by glycerol? Okay, it has the 3-hydroxyl group. Okay. So ester of the fatty acid with glycerol is the oils or fats. Okay. So here are still some new terms. Okay. So fatty acid we can say is the carboxylic acid, but the number of carbon will be more than 10. Okay. So we can call it an ester actually with alcohol glycerol. Okay. What you mean by glycerol? Alcohol with 3-hydroxyl, 3OH. In other words, actually this we can call them as oil or fats that we learned in our previous lesson. Okay. Now, what are the sources of oil and fats? You still remember? Okay. If oils, it is come from where?
Plant.
The plant or vegetables, right? Okay. Good. Vegetable. Vegetable oils and fats come from animals, right? Animal fats. Okay, Now, how to prepare the soaps from the oils and fats? Okay, soap are prepared by hydrolyzing the oils or fats in, okay, potassium hydroxide. Or sodium hydroxide. These two actually are the strong alkaline. Okay, sometimes if the common name or somewhere you can see the word lye, L-Y-E. But in the lab we'll call it sodium hydroxide. Okay. So this reaction is called what? It's called saponification. Okay, this is a new term. Saponification. Okay, saponification. So this is a new term for you, saponification. Okay, the process to produce a soap. Okay. Okay. Now, what is saponification? It's a process involved the type of saponification. Okay, is the process to produce a soap, right? Okay, to produce a soap in sabun. Okay, now carbonification is a process involve what? Involve the hydrolysis. Hydrolysis of oils and fats with concentrated sodium hydroxide solution or potassium hydroxide solution. Okay, the products are glycerol and the salts of fatty acid with which are the salts. Okay. Now let's see. Okay, let's see how is the reaction. Okay. So oils and fats react with the strong alkali must be concentrated. Must be concentrated. And normally in the lab we will produce very concentrated one, roughly is 5 mole per liter. Then undergoes the saponification, it forms the glycerol and sodium salt of fatty acid, that is the salt. It has two products. One is glycerol, one is the salt. Okay. So let's see. So this is a oils of fat. Okay. This R, remember, it has the N more than 10. More than 10. More than 10. Okay. But they are connected like this. Okay. This is oil of fat. Okay. In our last session, we have learned this. Okay, react with the alkali. Let's say sodium hydroxide or potassium hydroxide also can. Okay, so during the saponification, okay, the glycerol is produced. Glycerol. So glycerol is what? Okay, you can actually see this. Okay, so during the saponification, so this one. You break. Okay. Not from here, it's from this one. So the OH, you go in here, go into this one. So you see, you connect to here. 1, 2, 3. Okay. From here, can I connect to here? Okay. So far, this glycerol, is that okay? Can see? Okay, my class. Hello.
Okay.
Okay, let me call Michelle. Okay or not? Samantha, okay or not? Okay, can I? Okay. So class after it forms a glycerol, right? So remaining, you see, these 3 parts is being released, right? Okay, so meaning that this part, and this part, right? Okay, so actually this one, it becomes a salt. How is it formed? So you see, it'll be like this. Okay, we shift the R to this side, easier for us to draw. Okay, if you want to maintain this one, also can. Okay, so here, like this, right? Okay, over here. Alright, so this one is negative. Then this one is sodium is from here. Okay, so sodium positive, be like this. Okay. So how many of it? 3 of it. So R here, negative, and A plus. R. Okay. Now, this R prime, R double prime are long change of the hydrocarbon change is the alkyl group. That can be the same or can be different. Okay. So depends to what is the original one. So meaning that maybe C10H20, for example. So the C here, the R here can be the same or can be different. Okay. So this is actually a salt carbon. Okay. So here the structural formula of the salt. Okay, actually you see here, this one is R. R we draw here. Okay, as C or double O minus and N plus. Okay, if you use the sodium hydroxide, you'll produce the sodium. If you use the potassium, it'll be K, hence. No? So, alkyl group, R is R, alkyl group, N is more than 10, more than 10. Okay? So, here, you can see the functional group for the salt is this one, COO. This is for salt. Sabun, COO. Any question? Anything you want to ask? Is that okay? Yeah? Now, let's see. Given different formula for the fatty acid derived from respiratory chemical formula of salt form. Okay, now let's see. Lauric acid, okay. Lauric acid react with the sodium hydroxide, it forms a sodium laurate. Okay, how about the formula? How are we going to draw the formula of the salt? Okay. Very simple actually. How? So actually during the formation, right? Okay, the OH, or H here, COO here. The H, you just remove it, remove the H. Okay, remove the H. So the remaining you just copy. Okay, C11, H23, then COO. This COO actually this one now, this one. Okay, then here got 1 minus. Okay, then sodium, right? Okay, so it's Na plus. Okay, if you don't want to draw, put plus minus also can. COO Na. It's correct also. Can so this is a sodium laurate, the salt. Okay, C11 H23. Okay, COO Na. Okay, now I would like you to try for sodium palmitate and sodium stearate. And then for your information, this one, the oil used to prepare the sodium laurate is coconut oil. Okay, palm oil, it forms the palmitate salt. Then animal fats used to form the stearate. Okay, now these two, please draw the formula. So, okay, done, class? Already? Okay. Finish, No response meaning finish already. Okay. For sodium palmitate, okay, sodium palmitate, can you type in the formula? What formula you get? Okay. Churning already. How about the others? Okay. Everybody get it? Okay. 31 COO NA. All capital letter. Oh. Okay. I think okay. The others okay or not? Okay, so it's C15 H31 COO NA. This Na can change to K, depends to what alkali use. Okay, if potassium hydroxide, we change to K, be potassium palmitate. Huh? Okay, next, stearic acid. So sodium stearate. Okay, can you type your answer? What is the formula? Okay, C17 H35 COO NA. Okay, very good. Okay, so C17 H35 COO NA. Oh, this one no need to memorize. No need to memorize. Okay, for me, you suppose you want ask you to memorize it. It will give you the formula. Then you have to know how to get the info from the questions. Oh, okay. Now preparing a sample of salt in the lab. In the lab, okay, salt can be prepared for the saponification. All right. Okay, you can get from the used cooking oil, such as oils for deep frying. It is also called recycled salt because it reduces use oil waste and thus eco-friendly. So the only ingredients need to use we use the used cooking oil, sodium hydroxide, and water. These three things only. And then if you want to add in some fragrance, you also can add in so that your salt it can be taste or smell better. Got some smell. Okay. So here, that's how we discussed already. Okay, now can you please try to draw out the glycerol and then draw the sodium palmitate. Okay. So draw now, everybody. Okay, class, finish already? Have you drawn your structural formula for the glycerol? Finish already, class? Yes or no? You need more time? Or we can discuss already? Finish already, class? Huh? Yes, huh? Okay, good. So let's check, check and then mark yourself, okay. To write the correct one for glycerol, okay, we have to separate from here, okay, this one. Okay, so this part you just copy here. H. Yeah, so separate already. So C, H, C. Okay, now here. Yeah, after it's separate, okay, remember you take the OH, right? Okay, so OH going in, OH, OH, OH. So this one is called glycerol. Okay, correct or not for glycerol? And the remaining, okay. So you have C. Okay, so C15 now. I put it to the right hand side and then H31. I think okay, it's okay like this. Then C and O. Okay. Then here it's Na plus. Oh. Okay, So draw 3 times, times 3, times 3. Okay. So this is a sodium palmitate. Okay, all correct? Correct or not, class? Okay, So when the oil or fats react with concentrated sodium hydroxide or potassium hydroxide solution, glycerol and fatty acid salts, which is a salt, are formed. The reaction is called what, class? Do you remember? Can you type your answer? What is the reaction called? Please type the reaction, the name, so that you remember the spelling. Okay, saponification. Saponification. Spelling, don't get it wrong in the exam. Saponification. Saponification. Another one in under cleaning agent is the detergent. Detergent. Now, what is the difference or comparison with the salt? Okay, now define the detergent is a cleaning agent that is not salt, not salt. So detergent are sodium salt of alkyl benzene sulfonic acid or alkyl sulfonic acid. Okay. Now the two common groups of the detergent, you can see this one. This one is sodium alkyl benzene sulfonate. Okay. This one is the sodium alkyl sulfate. Okay. These R represent the long chain of the hydrocarbon. Okay, more than 10 or so. Okay. Now, if compared to the salt just now, you see in the detergent, okay, its functional group is this one. It's a sulfonate. Okay, sulfonate or sulfate. This one. As now as O. For salt, it is this one. COO, COO. Okay, COO. Okay, carboxylate. But for the detergent is sulfonate or sulfate. Okay. So this one normally in the objective, the following which one is a salt or which one is a detergent. So you go to find the functional group. Very easy to recognize. Now preparation of the detergent not that popular. Okay, saponification is more popular compared to preparation of the detergent. Okay. So what are the resources to make the detergent? It makes from the petroleum fraction. Petroleum fraction. Okay, and the sulfuric acid from the contact process. Okay. So what are the processes involved? Okay, sulfonation or sulfation. Another one is neutralization. Two processes. Sulfonation and then neutralization. Okay, let's see. Okay, preparation of the sodium alkyl benzene sulfonate. Okay, because now we know that it has two types. So we look into the first one. Okay, so sulfonation of the alkyl benzene. So this is the alkyl benzene. Okay, so this hydrogen with this sulfuric acid. Okay, these two combine. Combine will release the water. Okay, then they will connect together. Okay, like this. Here connect already. So this one is the alkyl benzene sulfonic acid. Sulfonic acid. So this is the first one, sulfonation. Then after that is the neutralization, correct? So under neutralization, okay, so sodium hydroxide solution is then neutralize the alkyl benzene sulfonic acid, but to produce the alkyl benzene sulfonate, which is the detergent. Okay, detergent. Okay, you see here for the this one sulfonic acid here or H with the sodium hydroxide. Okay, so this one forms the water also. Then here, okay, this SOO, and here. See? So this one is a detergent. So sodium alkyl benzene sulfonate. Yeah. Here this part, you in here will be replaced by R. Replaced by R. Okay, you don't care what is this. You just follow the one given here. Okay, so this one is a sodium alkyl benzene sulfonate, which is one type of the detergent. So another one is sodium alkyl sulfate. Okay, actually almost the same. Sulfonation of alcohol. Okay, so concentrated sulfuric acid is reacted with long change of the alcohol to form the alkyl hydrogen sulfonate. Okay, again, you see the same. H and OH combine to form the water. And these two combine, connect together. Connect it. And H here. This is connected. Okay. So this one is a sulfation. Sulfation. This one is sulfonation. Name only, but the process are the same. Okay, after that, neutralization. Again, we are using the sodium hydroxide solution. Is then neutralize the alkyl hydrogen sulfate by producing sodium alkyl sulfate, which is another type of detergent. Here. So sodium alkyl sulfate is another type of detergent. Okay, any question? Anything you want to ask us? Okay, any question you just ask. Okay, now this part more important. Okay, this one everybody must know. Okay, so the cleansing action of the soap or detergent almost the same. So what are the ions produced when the soap ionizes in water? So the general formula for the soap is R, RCOO Na plus or RCOO Na K plus. Yeah. When it ionizes in water, produce sodium or potassium K ions and the salt anions RCOO minus. Okay. Kevin, later on we are going to discuss this question in hard water and soft water. Hold on. Okay, you are so fast. Okay, now detergent and the structure of the salt and ions. Okay, so this one is a carboxylate ions, right? Okay, this one is the alkyl group. Okay, so R is a hydrophobic, is repelled by water. So this one is actually, or we call it HAL. Okay, this one is called head. Okay, so here the tail is alkyl group, long change of alkyl group. Okay, here I would like you to note down or highlight this hydrophobic part or hydrophobic tail. Okay, it is non-polar and no charge, soluble in oil or grease. Okay, highlight this too. The tail, hydrophobic tail. Okay, soluble in water. Repelled by water means insoluble in water. Okay. Now the head is a COO, is a carboxylate ion, which is okay here. Highlight hydrophilic. hydrophilic, soluble in water. Then it is insoluble in oil or grease. Okay. Philic actually, philia, it comes from philia. Philia means love water. Hydro means water, or hydrogen and what hydrogen and oxygen. Hydro means water. Hydrophilic means love water, means soluble water. Phobic means phobia to water, or repelled by water. Okay. This one is called hydrophilic. This one is called hydrophobic. Okay, talk down. This one soluble in water. This one soluble in oil or grease. Okay. And an example. Okay, we look into here. If this one given to you, okay, the head and the tail, hydrocarbon change, or we call it just now. Okay, can you type what is the name for the hydrocarbon change of the tail? Okay, this one I write already. Hydro what? Hydro. For it. Hen. Okay. Remember the spelling. Carboxylic ion on the head. It's a hydrophilic. Hydrophilic. Okay. And hydrophilic. This one is a hydrophobic. And this is an ion, that is a neutral. A simplified representation of the salt and ion with this. So explain how the hydrophobic and hydrophilic part of the salt works together to remove the salt and greasy stains on the cloth. Okay. This one. Detergent almost the same. So during the cleansing action, okay, the tail, it was soluble in the grease. Tail. Then the head will be soluble in the water. When the tail go into the grease, it will pull the grease lifted out from the cloth. And you can see it will be removed. Okay, when you wash with the water. Okay, now how are we going to explain? So this is a suggestion. Okay, so the salt, okay, salt what? Ionize in water to produce free-moving salt anions and cations. Okay, so we will focus to the anions, the hydrophilic head with the hydrophobic tail. So salt and ions reduce the what? Reduce the surface tension of water, which will increase the wetting ability of the water. So therefore, the water wets the dirty cloth. Okay, it can wet the dirty cloth, make it wet space. Okay, next, what happens? The hydrophilic part of the salt. Okay, salt and ions, right? Hydrophilic is an ion, right? And ions dissolve in water, while the hydrophobic part dissolve and penetrate into the grease, in the grease. So they have two parts here, hydrophilic and hydrophobic. Okay, next, what happens? So you see here, the hydrophobic part, it will penetrate into the grease here. This is the cloth. So hydrophilic part, it will maintain in the water. Here is the water. Yeah. So by the movement of the water during the scrubbing and rubbing, during the washing process, right, you need to scrub it and then you need to rub your cloth, right? So the grease is what? Lifted off. Okay, it's lifted off the surface. Okay, you put up lifted. Okay. Then the hydrophilic part of the salt and ions surround the grease, and then the grease is suspended in the water, right? Okay, you go in and then you suspend it. Then the grease is dispersed into what? Into small droplets. Okay, this one is consider bigger one, then you maybe cut it to half, okay, becomes the smaller droplets. Then the small droplets do not redeposit on the surface of the cloth due to the repulsion between the negative charges on their surfaces. Okay, here you see, all have negative charges. Okay, so it won't go back to the stick back to the cloth anymore. Then the droplets are suspended in water, forming an emulsion. Okay, emulsion. Then you see here, this one is called the emulsion, or small droplets of grease. We call it emulsion. Okay. Then rinsing away the dirty water, remove the grease droplets, and the surface of the cloth is then clean. Yeah. So this is how the cleansing action takes place during the cleaning of your cloth. Yeah. Then detergent actually almost the same. Okay, just the head is different here, because the head is the sulfonate for the detergent. Okay, for the soap will be carbonate. Carbonate. Okay, so for the detergent, detergent dissolved in water forms the detergent and ions and sodium ions. Okay, for example, ionization of the sodium alkyl sulfate will be like this. So it forms this one is an ion, this one is a ions. Okay, so here we can also specify. So this is the head. Okay, so this is the head, and then this is tail. This is head. Okay, but the function are the same. Okay, so the structure of the detergent. Okay, you can see this one is called what? Hydrocarbon chain of hydrophobic, right? The head hydrophilic. Hydrophilic. This one also the same. Hydrophobic. So it's hydrophilic. So the cleaning action of the detergent is very similar to soap. Get the hydrocarbon chain, or the tail, dissolve and penetrate the grease, while the head, okay, head or hydrophilic part. So here we can say sulfate ion or benzene sulfate. Okay, which is a hydrophilic now. Okay, remain. Okay, and then the process are the same. Okay, the process are the same. So then you can clean the soap. Okay, now this now Kelvin, did I ask a question about the hard water? Okay, hard water. Okay, then soap and detergent, is their effectiveness the same or not? Okay, so this part we are going to discuss in detail. The effectiveness of the cleansing action of soap and detergent. So under this subtopic, you have to know one type of water. We call it hard water. Again, bukan air keras, it's called air liat. Okay, but normally we call it air liat. So what is hard water? So hard water contains a high concentration of calcium and magnesium ion. Okay. So normally where you can see the hard water, very important one would be the seawater. Okay, seawater. It contains a lot of calcium and magnesium ions. So we can call it hard water. Then in the lab, can we get the hard water? Yeah, very simple. The distilled water, you can heat up calcium ion or magnesium ion. Now, hard water. Okay. Now, what is the effect of hard water in the cleansing action of soap and detergent? Okay. So this one, there are some things that you need to know. Okay. So the effectiveness of the soap is reduced when you use the hard water. So in other words, soap is not effective in hard water. Okay, why? Okay, why? So the reason is the calcium ions and magnesium ions from the water, right? Okay, so it reacts, react with salt and ions to form the insoluble scum. In terms of scum, in VM is kekat, kekat. K-E-K-A-T, okay, but normally in English it's called scum, which is insoluble. Okay, so let's see this one. Yeah, so this is steric and ions. Okay, let's see this one. So when it reacts with the magnesium ion or calcium ion, so it will form insoluble salt. Okay, insoluble salt, which is a scum. Okay, so what is the formula? Very simple. Don't worry so much. We just copy C17, H35, and COO, right? Okay, minus, correct. Magnesium is 2 plus. So you just interchange the charge. So this one, bracket, 2, correct. Then N. Okay. Any questions? If you write it in front, also can, also correct. But normally, if you see, all of us will write the magnesium at the back. This one is the organic salt. No? As long as you see, it involves an ion of carbon like this, right? Okay. Normally, you will write it first. The carbon fiber or C fiber. Okay. Any questions, class? Anything you want to ask? Can follow or not? Okay. So this one is called scum, scum or insoluble salt, insoluble salt, which is solid. Okay. Then for the calcium, also the same, C17H35, COO, or 2 calcium. Both are scum. Okay. Then what is the effect? Insoluble salt. For formation of scum, formation of scum reduces the amount of salt availability for cleaning. So meaning that it will reduce the cleaning action. Okay, and then this scum, it will form and then it will stick on the cloth because it's solid. So it stick there, and then you will see a lot of white solid stick on your cloth. And the cloth is become very ugly now, and then it's very hard. Okay, because of the scum. Okay, so meaning that in hard water, the salt is not effective. It's not effective. Okay. Now let's see. How about the detergent? Okay, detergent. What is the effect of the hot water to the cleansing agent of the detergent? No effect. No effect. Because detergent and ions do not form insoluble scum with calcium ions and magnesium ions. This means detergent can act as a cleaning agent in the hot water. Thus, detergent is effective than salt in the hot water. Okay. A lot of students feel that detergent does not react with the calcium and magnesium ions. No, they still react. Detergent and ions still react also. Okay, it will react also like this, but the product's form is not the solid, it's a soluble salt. So it can be washed easily. Okay. So first question, hydrophobic, hydrophilic, right? Okay, so this one is a salt, salt. You can see COO carboxylate. So state the property of hydrophobic and hydrophilic part of the salt and ions. For class, what is the answer? This one I would like to ask Adeline, what is the answer? Adeline, what did you write for this? Hydrophobic and hydrophilic. Okay, hydrophilic, soluble in water. Okay, very good. Okay, how about the hydrophobic? repel from water, or if we want to write in solubility, it's soluble in where? Hydrophobic. So hydrophilic, okay, soluble in water, okay, and hydrophobic, insoluble in water or soluble in oil or grease. Definitely is correct, insoluble in water, but we mentioned where it's soluble in, soluble in grease or oil. Is that okay? Okay, good, Adeline. Okay, next. Soap used to wash our daily stains on cloth. Explain the cleaning action of the soap on the oily stain. Okay, so for this one, right? Okay, you can, quite long one, quite long one. Okay, this one you can refer to here. Okay, the cleaning action, you can refer to here. Okay, how it cleans the dirt. Okay, you can refer to here. It's a quite long one, okay. So how it cleans. Okay, so this one I do not discuss with you here. You can refer to the notes as well. Okay, now question number 2. Okay, question number 2. Identify the cleansing action agent X and Y as the soap and detergent. Okay, so which one is soap? Which one is detergent? Yeah. Okay, Ellie, which one is soap and which one is detergent?
X is soap and Y is detergent.
Okay, very good. Okay, this one I hope all of you can recognize. At least you can recognize. So this one is X, this one is Y. You can look into the functional group. Okay, good. Now draw the hydrophilic part of the cleaning action X and Y. So you can draw it correctly. Okay, so hydrophilic, right? Hydrophilic. So hydrophilic is which one? Okay, so hydrophilic. So you can see for X, so hydrophilic, so it's the head, right? Okay, so it's this one. This one. Okay, and then Y is this one. Right? So you just draw it here. So it becomes it's E carbon or and then this. So this is the hydrophilic. Yeah. Okay. Then for Y, okay, Y is this one. Okay, for detergent, so S O O. Okay, correct on that? Next. And now state the name of the part of the cleansing agent of X and Y. That is soluble in grease. Okay. So what is the name for the part? Recall just now. Question 1 already mentioned. It's called hydrophobic. Okay, hydrophobic. Now, soap here, soap is ineffective as a cleaning agent in hard water. Okay, explain why. Okay, so you can refer to here the soap and detergent, right? Okay, soap and detergent. Okay, soap reacts. Okay, soap reacts with calcium ions and magnesium ions to form a scum, right? Okay. Then formation of scum reduce the amount of soap for cleaning. Okay, so these two points. Point 1, this is point 2. Okay, page 205. Okay, this is your answer. Now state one advantage of detergent over soap. Okay. What is your answer? Kevin, did you write something for question E? Can be used in hot water. Okay, it's very general, can be used. Salt also can be used, right? Just it is not effective, correct? It still can use, but not effective. So it must be very specific. So detergent is effective on do not form or does not form scum when react with calcium and magnesium ions in the hot water, right? So it is effective in hot water. Okay, but your idea is correct. Can be used, but can be used is very general, very general. So in exam, you write in more details so that you can. It has a higher solubility than water in the hot water. Eddie, your answer here has higher solubility than water in hot water. Then salt, higher solubility than salt in hot water. Solubility. Here, higher solubility, both actually, if I read your answer here, right? Solubility means salt is soluble in water. Detergent is also soluble. Then detergent has a higher solubility. Here is not that accurate because here I think you want to mention the product form, okay, during the reaction with the magnesium and calcium ions. It is soluble in water, and then the other one is insoluble in water, right? Your meaning, I think your meaning is like that, but you better be more specific also, okay? So it won't form scum, okay? When it react or when it used in the hot water, okay? But salt will form scum when it used in the hot water. Then from here it's very straightforward, okay? The marker is knowing your concept, right? Or you know that the detergent is more effective compared to salt. Okay, So you can mention what detergent. Okay. React with magnesium ions and calcium ions in hot water. Okay. To form soluble salt. Okay. Means no scum. No scum. But stop react with magnesium and calcium ions in to form scum. Okay. So you can add in another summary here. So detergent is more effective in detergent is more effective than salt in the hot water. Okay. Then one of the properties of the salt and detergent is that they can form lather, okay, with water. So what is the function of the lather? Lather is a way, way. Okay, so what is the function of the lather? Okay, or anyone will write some answer? Can you share with us? Wash off the grease from the surface of the substance. Yes, very good. Okay, so that is a function. So it helps to wash off or suspend the grease particles so that you can wash off the grease. Yeah. Okay, Kelvin, your answer is correct. Okay, so it helps to suspend. Okay, the grease particles. Okay. Okay, Any question so far? These two? Okay. The main concept of what I have discussed with all of you just now. Okay. I hope all of you can remember, get the main concept. The question normally will be asked you about all these concepts now. Okay, next. Okay. So the last part of today's lesson now. Okay, let's do some comparison. Okay, soap and detergent. Where is the source? Soap, where is the source, class? It comes from animal fats or vegetable oil. Okay. So where is the detergent come from? Another one is the ROSO3, then Na. So this one is actually here you just need to focus to the functional. This one is SO3, this one is OSO3. Okay. So the structural hydrophilic will be like this. Okay, this one there are two here. S another one is okay, there are two structural formula for hydrophilic, the head now. So effectiveness in soft water only. Okay. Soft water is the normal water like the distilled water, tap water, all these is considered the soft water. Normal water. Inside there no calcium ions, no magnesium ions. Okay. So for detergent, effective in both soft water and hard water. Okay. Formation of gum. Okay. This one, you will form yes. Okay. This one, no. So pH for soft, slightly alkaline. Okay. Okay, for pH, this one is pH is modified to suit the cleaning part. Okay, modify to suit the cleaning parts. Okay, meaning that for the detergent, actually it can modify the pH. Depends to which task for this detergent want to work with. It can be modified. So effect to environment. Okay, so a salt actually is better, biodegradable. Okay, so no pollution. Okay, but for the detergent, it's non-biodegradable. Okay, so it will cause pollution, no? Cause pollution. So here is the comparison about the soap and detergent. Soap and detergent.